Hello, everybody. My name is Martin Janiczek. I am currently working with GWI, Global Web Index. And before I really start sharing my story, I want to quickly tell you about what the company does. It will be important for the story later. So GWI is an audience insight company, meaning it profiles and surveys consumers, basically all internet users aged 16 to 64. And it gives them these huge questionnaires, and when it gets the answers back, it lets its customers query the answers and find interesting insights to understand how their target audience thinks, how they think about certain topics. So, for example, insights like, okay, if you ask who owns an iPhone and segment those people by age groups or by gender, then you find that 24% of asked men own an iPhone compared to 28.3% of women, for example. Or we have had a COVID special questionnaire. So one of those insights was the number of knowledge workers using Zoom has increased by 315% during the pandemic. So insights like that. I have given you a COVID-related example, but the questions are really very generic, and historic answers are available, so you can see the trends happen. You can show what percentages of people were thinking so and so about a topic. This year, that year, we are splitting it by quarters because that's our data addition cadence. So you can see how, for example, the COVID pandemic changed, consumers thinking about, I don't know, company being, environmentally friendly, for example. So you can see how it changed. So the application that we are developing lets you query this huge amount of data and find those insights, and you can export it to PDF, PNG, or like Excel chart, Excel spreadsheet, and send it to your boss if you are like a marketing people. So that's what the company does. And with all that, I have a tale to tell you. It was the night before Christmas. Well, almost. It was about 2 weeks before Christmas, 2020. And the chatter in our company's Slack server was beginning to die out as folks got on holidays and got out of their offices and computers. And there was one message among all the quiet that caught my attention. In our backend developers channel, and mind you, I am a front-end developer, like web developer, the team leader posted an inconspicuous zip file called rar.zip, which I think is very funny. And he said, here it is, working engine in 500 lines of code, including import and export. Now, a bit of context, what this engine does. Well, first of all, this engine exists already. This was just like a small version of it. So we have this huge amount of data, basically true, false answers, and the engine that the team leader is talking about is tasked with querying it and aggregating the results, right? So filtering those true, false answers and summing them together and giving you numbers like 500,000 people think this. So we then visualize it as some kind of attractive bar chart or whatever, and you can do whatever you want with that. So that engine exists already. It uses Elasticsearch database, and it contains gigabytes and gigabytes of data, to which we are adding more data each quarter. And it's not very fast anymore. And scaling it is tricky, because each time we want to scale the database, we have to double the resources. So it might have been, you know, fine in the beginning, but after you double a bunch of times, it gets quite unwieldy and quite expensive. So yeah, we are missing that granularity of scaling up just a little. And it's definitely, you know, getting slower as more data comes in. So naturally, over the years, there were a few people who thought, you know, about rewriting that using some different approach, some nice optimization. We have a bunch of private repositories on GitHub looking like that, and none of them really caught on. But it was definitely in the back of everybody's mind, or like the backend developer's mind, that, you know, we are basically the frog being slowly boiled alive. So the time was nearing when our Elasticsearch database just would not be able to cope with the data and would just fail, and I don't know what would happen then. So with all that in mind, you know, I have seen the Slack message. The team leader has essentially written a simplified, stripped down version of what the database does and the code interfacing with it does. And that gave everybody an opportunity to like tweak or reverse engineer or port something small and self-contained, instead of, you know, the full production ready thing with all its edge cases. So you can imagine the reactions. Oh, I'm going to play with this over the holidays. Oh, I'm going to try writing this in Go with, you know, this cool data structure or algorithm, and so on. And at this point, I enter the picture. Again, I am a front-end developer. I probably have no business, you know, reading that, but I'm supposed to consume that service from the front end. I maybe understand it from like 10,000 feet view, but I know very little about how it works internally. So normally I would look at that and say, yeah, whatever. I have better stuff to do with my Christmas, like Advent of Code. By the way, shout out to everybody solving Advent of Code. But, you know, as luck would have it, I was just about a week into learning APL. I gobbled up Richard Park's APL workshop up to about a section about rank. The workshop is amazing, by the way. It has really helped me with my like first steps into APL. I was lurking the APL Orchard chat room, as sometimes I needed a bit of help, and there was always somebody, you know, Adam is there, or a bunch of people are there who are always happy to help me and unblock me. You know, the classic question, have you tried to search it on APL card? And so I was slowly starting, you know, I was getting comfortable with APL, at least as much as you can get comfortable with it after like a week or two. And I was starting to look for a bit larger real life project to try APL on. So you can understand when those two things combined, me learning APL and the other team leader, you know, posting that prototype code just before Christmas, it was as if, you know, rays shone down from heaven on my, I don't know, keyboard. So it was a really great timing, and I dove in. And over the next probably like 2 weeks worth of evenings and nights, I started chipping away at this problem from many different angles. One thing was, what's even the source data to this thing? How does it look? How do I consume that from within APL? You know, how do you read files? How do you parse JSON? Turns out it's all JSON. It's all huge gigabytes long JSON files. So can I somehow pre-process that so that I would hold just the really essential data for the service in some kind of packed format, or, you know, what can I do? Another thing was, what's the essential algorithm this service should perform. What's the core idea? It was hidden, even in the small prototype, it was hidden beneath explicit loops in the decode. Some of the backend developers probably knew or remembered parts of it from the current production service, but there wasn't much to go on for me as like outsider from our wikis and documents. Nothing really explicit except for the code itself. And lastly, the third problem was I/O with the user, input output. So how do users use the service? What do they send in? What do they get back? Again, it's all JSON, so I needed to figure that out. And being this naive, excited greenhorn, newbie, I wanted to blow everybody's socks off over the Christmas with implementation in a language no one, none of them has ever seen, none of them can read or write, and that is older than any one of them. So I was just, I just dove into this pool of unknown, this whole new world, and I immediately bonked my head because the first big hurdle I needed to overcome was working with tree structures. You see, it's quite easy in APL to decode arbitrary JSON. As I learned, you just do quote JSON and basically you have it parsed. Really simple. But how do you then work with it? What if the JSON contains a tree structure? It can nest arbitrarily long, arbitrarily deep. I can have all these ands and ors, so I can have expressions like that, but they can also look like that. It's perfectly valid. If that, I don't know if it makes any sense as like audience, as like person, but yeah, you could definitely create that expression. So my early evenings were spent trying to understand how can I query this in the APL JSON matrix format and keep my sanity. And my whole being was screaming like, hey, this would be so easy in another language. You have algebraic data types in Elm and Haskell. Why are you trying to fit this square into this circle hole? Why are you trying to fit these trees and custom types into basically array of numbers and characters? You are using the wrong tool for the job. And I almost gave up, but fortunately, there was one Google search result that gave me hope. And some of you probably already know, it was Aaron Su. So that's the person behind the Codefense compiler. And his videos and papers are what single-handedly got me through this. Otherwise, I would probably give up. So in about 3 nights, I would say, reading the paper over and over, copy-pasting snippets from the paper into like the Dyalog REPL, and losing hair over why does this have different results for me than from him, and figuring out, okay, yeah, he uses Code.io is 0 and I am using Code.io is 1 because that's the default. So yeah, figuring that stuff out. So yeah, about 3 nights of like understanding his ideas and running them on my data, I inched closer and closer to where I needed to be. And if that seems like too long of a time to spend on one problem, note that I still barely knew the language. I was a 2 weeks old APL baby or seedling or whatever. But it all felt like one huge, great, exciting puzzle. And folks in the APL Orchard chat room were always ready to help, or at least encourage me when their experience with tree structures was also lacking. So finally, I had the user input JSON query roughly parsed, and now I needed the data, the source data, before I could try to execute the query on top of it. Now, the data, as I said, it's one huge gigabytes long file of JSON objects. So there's basically one object per respondent, per person answering the questionnaire. And, you know, there is some metadata, like there is weighting, which is basically a float number to help with, you know, like selection bias or something. So there is some stuff I needed to pick from there, but mostly what I was seeing is, hey, those are booleans, those are bits. I can probably, you know, pick them. I can store like the column in column header. I can probably store the like the keys, the data points, you know, codes or like the answer codes, and on the row headers I will have, you know, each respondent. So I can probably make a matrix from this that will be much smaller. And really, when I did that, when I pre-processed those, you know, huge gigabytes long JSON files, I got 50 megabyte, you know, APL matrix saved on the disk. So I had 100 times smaller files than, you know, what was in the database, and that was huge because the prototype that, you know, the team leader posted, it used the original JSON files, and instead of pre-processing it like I did, because I didn't want to wait, you know, 2 minutes each time I started the program, so I just saved this small array. They did the pre-processing or processing on each startup. So I, you know, if nothing else, if everything else failed, if I didn't, you know, finish the experiment, I thought, okay, this is a good thing to replicate in the other service. So there was one, you know, big win, or like one realization that, okay, we can do this optimization, it will be much better. So I knew I was onto something. Now the next problem was executing the query. So executing the query on one respondent is pretty easy, because for the leaves, you just have to basically select their, you know, answer code from, basically you just have to do intersection of them and the answer code. You get Boolean back, and that's it. I'm simplifying stuff. There are, you know, it's more tricky, but not much. So it was pretty easy for the leaves of the expression of the tree. And you can, you know, if you think about it, if you have all the leaves, all the children of a node, the and or not, they are pretty simple too. So, you know, if you have the children ready, you can just do not or and of all these, or of all these, right? And reduce and or reduce, pretty simple. And so I knew that, but the problem was that I didn't, you know, I didn't have all the children ready. Sometimes I needed to do stuff to a leaf before it was ready. So there was this kind of dependency tree. And for some reason, instead of doing what I would do in all the other languages, like just running it recursively from the top down, I picked approach. Basically, I think it could be like a while loop, but basically I went from the bottom up, and that's done with this beautiful operator. So it basically runs stuff until you know, it's until the two things are equal. So I call it fixed point. So I have managed to that. I was very proud about myself, and I believe I even wrote Aaron an email about this. I was like, hey, this is great. Do you have any more ideas on like how to do this better or differently? And he said, yeah, it might be, most performant if you convert it to like prefix notation, like a stack, and execute that sequentially. But I didn't go there. I was just too happy to have my own crude solution, and worked pretty nice. Okay, so I could execute a query on a single respondent, and I got a Boolean back. So now, just running that on all the respondents, APL makes it very easy, almost automatic. So my work was almost done. I had a working prototype, and since I have been posting my results to APL Orchard, folks from Dyalog even got into a call with me. I think it was Adam, Morten, and Brian, and they listened to me talk about this stuff excitedly, and they suggested improvements, and it was really funny. One of the improvements took, I think, about 3 characters to implement, and it has shaved 1/3 of my query running time, which was just huge. I was blown away. It turns out it's faster to transpose the matrix and be able to read from disk one huge bunch of data at once, instead of reading it by 1 byte many times. So that was a silly mistake on my part, but it took 3 characters to fix, which again, I was just blown away. I was having a great time. Okay, so at this point, I had a working prototype after about 2 weeks of puzzle solving. Not only that, the prototype was only 172 lines of code long, and it was much more performant than anything anybody in the company has previously written in their prototypes. I think it bears repeating. After 2 weeks of puzzle solving, a programmer who in total knew APL for about a month wrote small prototype that beat all other prototypes as if by magic, automatically. So I was just, I was sold. And that's when people started coming back from holidays, and they read all of my excited messages on the Slack. Yeah, 2 colleagues in particular took up the gauntlet and wrote a Go prototype to see how good or bad the performance would be there, with all the multitasking, all the Go routines, green threads, and so on. Note that my APL code was still single-threaded. It doesn't really make sense to spin up a new OS thread using isolates or whatever for the query, because the query itself takes like 3 to 20 milliseconds. So the overhead would be just huge. And I tried this like multi-threaded multitasking for the pre-processing stage, but for some reason it didn't work. But I was happy with the performance there, as it was, I believe, 2 minutes per gigabyte of the source JSON. So it was pretty nice. And so they have they have ported the deep prototype into Go, and it wasn't fast at first. It had many of the problems of the deep prototype, and I often commented on that. Hey, you are doing it this way, but I, in the APL prototype, I'm doing it this other way, and perhaps that's less work, And they always said like, and incorporated the suggestions, and the code got faster. So, there were messages like, I'm not going to sleep until Go is faster. Well, that's going to be a sleepless century, said another. And, they told me, stop making Go look so bad and APL so good. So there was, it was just competition. There was considerable audience gathering on the sidelines, presumably with popcorn in their hands. It was huge fun. But in the end, after, I presume, some sleepless nights, they got too fast. They just put in enough work to make it faster. And although they didn't have the auto vectorization that I got from APL for free, they have used some clever data structures, and they have tweaked their multi-threading parameters, and they won. They just simply won. I tried to combat this partially with just spawning 8, because my machine has 8 cores, spawning 8 of the dialog processes. Just each of them would be a copy of the same single-threaded program. Just spawning 8 copies of these and load balancing them with Nginx, and it helped a little. So my code, it got faster. The responses got, it was more responsive even under load, but it just wasn't enough. After they copied all the good ideas from the APL code in Go and got all the benefits like instantaneous source data loading times and small memory usage, we compared the experiments one last time and we got this. So smaller is better, more to the left, shorter is better. So they just blew me out of the water. They were just blazingly fast. And that might be where the story ends. You might think it is a sad ending to the story, and it might be, depending on how you look at it. We didn't get APL into production. Dyalog APL has just one new convert, me, after all this, not 5 or 6 people. But on the bright side, APL has massively shaped how the final solution looks like. It has shown us what are the running and loading times and memory and disk consumption. What is the performance that we should strive for? And this 172 line prototype that took 2 weeks to write has prevented us from being satisfied with a worse solution. It has created competition for the real Go solution that will have all the bells and whistles and talk to Google Cloud Storage and gRPC and whatever. It has created competition for the solution that has forced it to be great, not just good, which I think is a great win. So yeah, I would like to summarize and end this story. It's amazing to me how this APL solution was optimal on so many levels without any real expertise on the topic on my part. Again, I barely knew the language, and I am not, very experienced with backend stuff or like with calculation stuff. But it has led me to the correct solutions and algorithms as if by magic. So I don't know how that happened, but it just did. I am a believer in the better math notation now that APL is called. And while in my normal programming life in other languages, I am normally big proponent of readability and long variable names or descriptive variable names. There is something really magical about the APL one-liners and function bodies being shorter than the function names and so on. Yeah, it was all a huge fun. And if you might have a service that you perhaps it's legacy service, you don't understand it. If you remove all the boilerplate and craft all the explicit loops from the normal imperative code, if you try to distill it into APL model of your core algorithm, it will give you understanding into how the parts fit together before you perhaps go and implement the real thing, with all the new insight. You have written it once already in APL. It has forced you to be really clear about what happens in the core algorithm, in the logic. And there's pretty good chance it's optimal, which again, I don't know how that happens, but it seems as if APL doesn't let you write it in any other way. And as evidenced by my example, my experience, beware, it might take you some effort to even, be more performant in the real code. Well, I'm saying it as if it's a bad thing about like the APL model, but the real production ready code, it might take you some effort for that to be faster than the APL model. So yeah, that's what happened. So to wrap this up, thank you, Richard Park, for your APL workshop webpage. Those were my absolutely first steps into APL. It was very nicely paced. Great interaction. Thank you, Adam, and the whole APL Orchard chatroom community. I admire you folks for your, code golfing, but importantly, you are very, very, very open to newcomers, and you have a huge focus and you place a huge value on teaching and helping us newbies. So if it wasn't for you, I might have given up long ago and written APL off as some, arcane, forgotten curiosity from 50 years ago. So you guys are, in my opinion and experience, absolutely essential stop in a newcomer's quest to get comfortable with APL nowadays. All the more in these COVID lockdown days when we can't have in-person workshops and meetups. So yeah, thank you for being there and doing what you do. Thanks goes also to the rest of the Dyalog folks who were on the call with me and shared ideas, so on. Morten and Brian, thank you for the improvements you suggested and even extending your libraries for my use cases. And I don't know if Aaron will watch this talk, but thank you, Aaron, for your work on trees in APL. I might not share your, everything fits on one page coding style, but if it wasn't for you, I would get stopped right at the start. I wouldn't get past the first hurdle. So your dissertation thesis and your talks made a huge difference for me. And I think that's all from me. Thank you, everybody, for listening.
Thanks, Martin. There is a few questions in the Q&A panel, if you're able to see those. I don't know if you'd like to answer them here on camera. There's quite a few.
Yeah, after I stopped sharing, I can now see the Q&A.
Cool.
Okay, so I'm reading the question by Randy. Please correct me if I'm wrong. The graph shows that Go is faster until it dies on early dev, but APL is still acceptable at the larger points. Okay, so I didn't explain that very well. It's basically like HTTP bandwidth benchmark. So it does 5,000 requests. And I think we have configured it to be, 15 requests at once. So Go stopped earlier because it was all done with the 5,000 requests earlier. So it was just faster, so it stopped after that. And we, the APL solution, it took longer to process those 5,000 requests. Did the tree wrangling code end up in the final solution, or was it an intermediate step while parsing the JSON? Yeah, so it did. I kept using some of those, I guess, like helper functions, or like getting from a depth vector to like parents vector and using that repeatedly with like the power operator that is still there. For me, it's a way to work with trees in APL. So yeah, that has stayed relevant and stayed in the prototype until the very end. You say that you are the only convert to APL, but did you get any respect for all that backend work you contribute? Oh, hello, Aaron. So you are here. Well, I think I don't know what the guys are seeing, you know, behind my back, but they were really impressed with APL. I think it was definitely, you know, it blows minds in more than one aspect. Like I guess the symbols are the first thing to be commented on, but they really, I think they were impressed that it was so fast and I guess succinct. So I think some of those might you know look into APL in their own free time later, but nobody said, hey, let's you know let's use the solution, let's keep APL in our like company code. So I think they were impressed, but they are maybe like a bit weary about like using that language or like that kind of language in production. So there might be, you know, that might be error on my like evangelism or maybe over competitiveness, but yeah, I think you know, like all the managers or all the heads of engineering and so on, they like to walk the well-treaded path, right? So they will always use Go if possible instead of even like Rust. So yeah, I think popularity is a huge deal for them. I don't know how to combat that. Maybe APL is better, you know, for like startups who don't have to, you know, tell managers, hey, this is worth it. It will make us, you know, faster, more competitive, or whatever. But in company like GWI, it's kind of hard to, I guess, fight for APL. Okay, so something like pachyderm, like make, it doesn't compute things that were already computed, would probably optimize away the extra pre-processing. Right, so I don't think there's much like needless work going on. The pre-processing only has to be done once, and then we can, you know, read the data from disk or whatever. And we only get new data files every quarter. So I think, I don't know, I suppose we don't have that problem that you are talking about. Sorry. Will you now prototype new code in APL regularly from now on, do you think? Yeah, so I don't come into these situations very often where we have brand new service or something, and from the ground up we need to implement something. And again, I am not a backend developer, so others might, you know, come into that situation. But for me, I think if I ever have the need for some number crunching, I will definitely, you know, remember APL and think about like, is this a good fit? I will probably try to write it in APL, but I'm not a person that, you know, comes into these situations very often. But yeah, APL has, you know, left lasting impression on me. I am still blown away, and I am still like fanboy of it, but I might wait for that kind of project that will need it. And do you think the APL solution might have continued to be the optimal one if a more experienced APLer had written it, or had APL reached its limit? So hard for me to say. To be fair, I haven't, you know, given the source code to, I don't know, Adam or the Dyalog folks to like go over it and say, hey, you did this, you could do better with that. I think they would find something, definitely, because again, I knew APL for 2 weeks when I started writing it. So I don't, even now, I don't know, you know, all the idioms and so on. But it seems to me that I guess Go having the multi-threaded, you know, support from the get-go might have an edge in this case. So I'm not sure whether APL could use all the potential of like multi-threaded machines. It's possible it could, but in the end, I couldn't make it any faster, and so I concluded, day one with Go. I might actually, maybe it might be possible for me to maybe open source it. I might have to ask some kind of, some manager, and then we might try to like make it faster if anybody's interested. But yeah, that might be something that happens in the future.